Welcome, everyone. It's great to have you join us for our presentation about offshore wind energy. Again, I'm Matt Molina. I'm the director of NYC H2O, and I'm joined by my colleague, Katie Strom. We're super excited to have two wind energy developers present tonight, and to present on a topic that's been a long time coming in New York and more crucial than ever in our drive for renewable energy, offshore wind. In 2019, New York State passed the Climate Leadership and Community Protection Act, which set goals of 70% renewable energy by 2030 and 100% renewable energy by 2040. Offshore wind energy is a necessary component to help us achieve these goals. If you've ever been to the beach and had your beach umbrella blown away and had to sprint down the beach trying to chase it down, then you know why offshore wind energy is a great idea. But like with any new project, community planning to inform proper planning is essential, and that is part of our motivation for tonight's talk. In tonight's presentation, we'll hear from representatives from two companies who are leading the charge, no pun intended, to develop offshore wind power in New York State. The first, Atlantic Offshore Terminals, which is a developer for the Arthur Kill Terminal, where a factory will be set up to assemble the massive wind turbine blades. And Leading Light Wind, which is the company that is coordinating the overall wind farm project. So without further ado, please join me in welcoming Boone Davis, the CEO for the Arthur Kill Terminal project. Boone, please take it away.
Great. Thank you, Matt and Katie, for inviting me to talk tonight. Looking forward to walking you all through, Arthur Kill Terminal and what we proposed and why we proposed and what this offers in terms of, key infrastructure to support the build out of offshore wind in New York and really throughout the U.S. I also just want to, thank the team at Leading Light Wind and Wes Jacobs, who's here with me tonight. He may be chiming in on some aspects of their project, which again is an offshore wind project that, if it's awarded offshore wind credits from NYSERDA, would be a user of Arthur Kill Terminal in, kind of using the space to assemble wind turbines and other components for its project. So, it's relationships like these that make projects like ours and theirs happen, and we're just delighted to be here tonight. Matt gave a great introduction there about offshore wind and kind of why we're here, but just to kind of paint a little bit of color on it. Offshore wind in the United States is a major emerging industry that's really been in the works for about the last 20 years. Currently, there's over 50 gigawatts of offshore wind planned on the East Coast, which is more than $200 billion of capital investment. To put that in perspective, a nuclear power plant is like 1 gigawatt. A large coal plant or a large, very large natural gas plant would be about the same. So this is a massive amount of energy, clean energy, that offers a unique opportunity to displace aging fossil plants and nuclear plants that line our coasts with renewable solutions that are in close proximity to these urban load centers like New York City, where we are, where there's a large amount of demand for energy and not a lot of land, especially on land, for building, giant solar fields or onshore wind turbines or other solutions. So offshore wind will be a very important part of the mix, as New York has acknowledged in the passage of its Climate Leadership and Community Protection Act in 2019, which again sets these goals for not just building out offshore wind as a resource, but transforming the entire grid and economy into a emission-free system. So it's a major undertaking, and again, Arthur Kill Terminal is really meant to be a key infrastructure project that will facilitate the offshore wind construction part of the equation. Support for offshore wind has also grown tremendously over the last 20 years. There's very strong bipartisan city, state, and federal government support This is really born out of decades of different development projects and efforts there, planning around resources, and also kind of the cascading sort of snowballing effect of bringing in different types of stakeholders that have an interest in seeing something like this built. So whether it's labor or local businesses that are looking to participate in really kind of heavy domestic manufacturing, or you're focused on the environment or environmental justice. All of those things are integral in offshore wind development as it's being rolled out in the United States. So it's not just about clean energy, it's about a lot of other things. And we try to kind of honor all of the different interests of our stakeholders in our approach to developing this project. It's something that we're very proud of. So on the East Coast, these 50 gigawatts of offshore wind, that's a lot of wind turbines. It's about 2,100 wind turbines. We have 7 that have been built in the United States so far, 5 off of Block Island in state waters, just sort of southeast of the island, about 3 nautical miles from shore, and 2 that are, I think, 20-something miles off of the coast of Virginia that were built more recently. Both of these demonstration projects have, sort of offered a chance for folks to really kind of see and get their hands on offshore wind energy in the US, myself included, and serve as really a good benchmark for studying things like environmental impacts and construction methods and everything else, planning, you name it. Importantly, 2,100 wind turbines is actually a bigger undertaking than even that sounds, because you also have to install the same number of foundations below the wind turbines. So that's over 4,000 wind turbines and foundations. And I'll get back to that stat in a moment when I talk about port capacity and what's needed there. Other recent developments in the industry that are worth noting is in February of last year, the federal government conducted a lease auction of new sites off of New York that resulted in $4.4 billion of revenue for the U.S. Treasury and 6 new projects. And Leading Light Wind and Wes and his team are one of those projects. And again, this results in hundreds more wind turbines planned for installation. So it just adds to the demand for ports, for workers, for vessels, for transmission places where you can plug in the power, and everything else that goes into offshore wind. Long term, New York has studied what it will need in terms of offshore wind, or what it may need in terms of offshore wind to meet those 2040 and 2050 goals that are more broad and focused on decarbonizing the grid and the economy. And New York's Climate Action Council suggests that almost up to 20 gigawatts of offshore wind may be needed by 2050. And so when we think about port infrastructure, we can't just be thinking about, well, what's needed in the next 5 years, but be thinking about how can we develop an asset that is going to be usable for projects in 15, 20, 30 years as the technology scales, weights could go up. These are very large components, and their efficiency is often driven by how big they are. And as the means and methods change. So I'm going to talk a little bit about the possibility of floating offshore wind in New York and the need for infrastructure that can support that. It's also worth noting that there's a bunch of other states that have ratcheted up goals equal to or exceeding New York's ambitions in offshore wind over the past couple of years. So this is not just a New York City focused effort, but really nationwide, going down to the Southeast and Gulf of Mexico and California more recently. So here you can see a map showing some of the projects in the sort of mid-Atlantic to Northeast region. And I've also highlighted some of the major supply chain facilities or ports or manufacturing centers, and tried to sort of make a distinction in the icons as to what role they might be performing. So the red wrenches are manufacturing port sites. Some of them, might be used to some extent for what we call staging and assembly. But to a large degree, these are places where factories have been proposed to manufacture, large steel foundations or wind turbine blades or cable or some other component that's, integral in each offshore wind project. Arthur Kill Terminal is a staging and assembly port. And so what we're focused on is the deployment of the wind turbines themselves and their subcomponents and the foundations, what we call the main components that go in each wind farm. Each one of these green circled areas offshore, hopefully you can see my cursor, is a wind farm site. Some of these sites have been sort of broken up into multiple projects. So you see different pins with different names on them. Those are individual wind farms, and they may be broken up further depending on, when and in what amounts the offshore wind farms actually get contracts to sell power. So those are known as lease areas, those green outlines. And again, the pins are project names. The orange pins indicate that the wind farm is still looking to sell, its power to the grid via some form of a solicitation or power purchase agreement. And so you see in the New York area, these are the 6 sites that I mentioned earlier that were just auctioned off for $6.6 billion. And Leading Light Wind is sort of circled here in yellow. So Wes, I just thought I'd sort of tap you for a second and see if there's anything you want to add about your project as you can see it on a map.
Yeah, happy to do that. And maybe just take a brief opportunity to introduce myself. So pleasure to be here at Wes Jacobs, and I'm the project director for Leading Light Wind. And Boone, I'll start off by calling you out that you actually circled our neighbor's lease there. That's Atlantic Shores.
I screwed up.
That's okay, because we work close, and maybe you can move it over there on the spot now. Don't worry about it. But we work closely with our neighbor, Atlantic Shores. But yeah, so that's our lease. Like you said, Boone, and you really did a phenomenal job to kind of teeing up this talk here and giving some context. But yeah, we picked up this lease just over a year ago in Boehm's New York Bight auction. So Leading Light Wind, like Matt said from the start, that's actually our project name, and the companies behind the project are Invenergy. Invenergy is the world's largest privately held clean energy developer. Up until this point, largely focused on onshore development, and this project actually is our first now of 2 offshore wind projects. We likewise picked up a lease at the end of last year off the California coast, so we've got a growing portfolio of offshore wind leases. And our partners, Energy Re. Energy Re is a New York-based affiliate of the related companies here in New York City, and we work closely together to develop the project with plans, like you said, Boone, to be selling into the New York market. And maybe just bears repeating for those that aren't as close to this as some of us living and breathing it every day. So as a developer, our role is to acquire the lease. Again, that's what we did just over a year ago. And then once we have site control, from there, the plan is to de-risk the site, develop the site, and ultimately secure a power offtake contract into a market. And the way that works for offshore wind at this stage of the game here in the US is it works through state solicitations. And it was back in January of this year that we submitted our bid into NYSERDA. NYSERDA is the state agency in New York that's authorized to procure power, clean energy on behalf of the state. We submitted our bid into NYSERDA to sell clean energy to the state of New York. The bid that we submitted is over 2 gigawatts, in fact, of offshore wind power into New York. So again, back to your scale comment earlier, Boone, this is very large scale energy development. And these projects, all of these offshore wind projects are a very big deal in the context of New York's climate goals. Specifically, that's it falls under the CLCPA, the Climate Leadership and Community Protection Act, where there's very ambitious and no doubt nation-leading goals to decarbonize the grid here in New York. So very exciting space to be a part of. Something that's a bit unique, very unique about Leading Light. We're actually the only American-led venture in the region, the only American-led company that's bidding into this NYSERDA solicitation. Like Boone said, there's only 7 turbines spinning and generating clean energy in the US at this stage. So it's very much a nascent industry. At this time in Europe, it's very much so an industry at scale. There's upwards of more than 5,000 turbines. So to this point, it's largely a European-led industry, while Invenergy and Energy Re are the first American-led venture in this region that are looking to bring clean offshore wind power into the New York and New Jersey region, and we're proud to do that. And I'm sure we'll talk about it more during this discussion here, but opportunities like the Arthur Kiel terminal are just great opportunities to ensure that New York truly can serve as the center of this new industry here in the US, and not only New York, but New York City. And we're really excited to be working with Boone and his team towards that goal.
Great, thanks very much for that, and I'll fix this. Anyone making maps of things in Google Earth will find that sometimes the pins and the logos don't line up, and this is my mistake. A couple other things I wanted to sort of show on the map are I provided a couple of additional layers here that folks might find interesting. One is the shipping lanes; those are the pink shapes that you see, and then the other is the bathymetry. And as you can see, there's sort of a defined contour of water depths that is somewhat apparent on the northern half of the New York Bight. This line right here is the 60-meter line. And so, in shallower waters, fixed bottom offshore wind tends to make sense below 60 meters. That's where you're basically installing the wind turbine foundation, in the seabed. Beyond 60 meters, it becomes a little bit trickier to do that economically, at least. And so it's really in waters deeper than 60 meters that you need to turn to floating offshore wind resources. And again, I mentioned the goals of the other states. New Jersey, 11 gigawatts, somewhere around here. New York, 9 gigawatts between this development area and then some developments over off of New England that'll run transmission cables. All of these sites will not, even fully built out, which is not going to happen, support the needs of the states. And so, more long term, if we're going to be accomplishing these, economy-wide decarbonization goals and using offshore wind and not some other resource, it will likely entail moving into deeper waters, because it's not just shipping lanes that sort of take away developable area. There are a lot of other marine resources that are studied by the government when they come up with where these wind farm sites can go. And that includes, fishing, that includes Department of Defense areas that need to be reserved for military exercises and training. There is a long list of dozens of things, if not probably 100 things, that are considered as part of the siting effort. And there are a couple other areas that are in planning down here. In terms of the government is sort of thinking about, well, what could work? And they've identified rough sites that could be whittled down. It's very likely that deeper water offshore wind is going to need to be considered. And New York has recognized that, and NYSERDA has already begun the process of studying deep water offshore wind in what they call their Master Plan 2.0, which commenced last year. So that's something that we think about when we go about siting for offshore wind. The other thing that I would just draw your attention to are the different port icons. So in green, I've sort of highlighted some of the, in red in South Brooklyn's case, some of the major staging ports that are under development on the East Coast. There's not going to be 100 of these. There's going to be, half a dozen probably at most in the East Coast. There's others one more rather down in Virginia that's under development, which I just didn't show because the map would have gotten too small. But each of these projects is roughly 30 to 40 acres. All of the green icons are unrestricted, meaning that they're not subject to bridge restrictions between the port and the ocean, which is important and which I'll go into later. South Brooklyn Marine Terminal is an existing port in New York Harbor that's being developed that is bridge restricted. It's very unique in that regard. But again, these are the handful of sites that'll be used for offshore wind deployment. So offshore wind deployment, what does it look like? What's the activity? These are photos from the Block Island Wind Farm, which I was involved in. A staging and assembly port is basically used as a construction staging yard. If you're building a skyscraper or a building or something, you probably need space in your yard to lay down wood and steel and materials. Offshore wind is no different. So these ports are used to receive and sort of stockpile these large, pre-manufactured components for assembly and testing prior to taking them offshore. Once you take these pieces of equipment offshore, it becomes very, very expensive to deal with any of the installation measures that you've left to be done offshore or any of the commissioning. It's much easier, obviously, to find an electrician up the road to connect two cables between towers than to put them on a vessel, send them out to sea, pay them to sleep overnight, et cetera. So you really want to be doing the work in port as much as possible, which by being outside of a bridge, we allow. And you also want to be very close to the wind farm site so that these vessels that are very, very expensive aren't traveling super far between the port and the wind farm site to do the installation. You want to be, doing this like an orchestra, very well-timed, all of your vessel movements and without a lot of downtime or wasted time. The goal is to get to the finish line quickly in terms of completing construction. And all of that also helps minimize environmental impacts, vessel emissions, you name it. I think I said earlier that a typical offshore 1 gigawatt project requires 2 to 3 years of staging port use. That's assuming 30 to 40 acres. So each one of those pins needs probably 2 to 3 years of a port to support its construction. Here you can see, kind of our view of demand for these ports for the next 10 years. And so I've color-coded the different staging ports and the different wind farms that have committed to or are likely to use, and sort of tried to label what those wind projects are. So as you can see, every one of these ports has a good stack of 4 or 5, large offshore wind projects that'll take 8-10 years to complete. Compounding that problem is the fact that most of these ports aren't yet built. Salem in Massachusetts has not yet been built. It has, I think, partial funding for construction, but that's still underway. New Bedford was built in 2014, so a long time ago. It's a bit small. There's some upgrades happening there, but that's constrained actually horizontally by a hurricane barrier, so you can't bring in all the types of vessels that you might need to use. State Pier is under construction. I think that'll be completed sometime later this year. That's a 30, 40 acre plus staging port that looks a lot like what we're proposing. South Brooklyn Marine Terminal is leased to Empire Wind and Beacon Wind projects. And this SBMT is still under development, and that has yet to begin construction, and that'll take probably a couple years to build. New Jersey Windport still under construction. So, all of this stuff is still, kind of getting established. And once it's established, it's all booked. So these new wind energy areas that were just auctioned off by the federal government, there needs to be a port from which they can be built. Otherwise, they'll be delayed. And by delaying these projects, you're increasing costs and likely increasing the environmental impact of continuing to rely on fossil fuels for our energy mix. So it's really important that we, Arthur Kill, and everyone else in the industry, states, federal government, are all kind of thinking about this from a master planning perspective and making sure that we have all of the infrastructure that we need to build these projects. Here's a diagram kind of showing you, what we're designing for. So these ports need to be, again, as I've said, about 30+ acres to handle, at least a gigawatt or so a year, potentially more as turbines get bigger, and you need fewer of them to build a project. You need to be on a deep draft channel. So these vessels are, they draw a lot of water and they're very big. And so they need to be in a place where they can actually get out to sea. They need to also not have air draft restrictions or width restrictions to be able to accommodate the assembly of the towers in the port, the use of jacket vessels, and a whole host of other things that I'll get to in a moment. You also need to have a long enough berth to be able to not have to delay your operations waiting for vessels to move out of the way. You need to have room for stuff to come in and go out at the same time without interference. Again, it's an orchestra. And then you need to have some basic facilities for your workers, small office, small warehouse. All this stuff comes and goes by water. You need to have parking for workers, but it's not like a lot of other port operations in some ways. And the key, so the area along the bulkhead needs to be very, very strong and able to handle not just the weight of a full tower, which can be up to like 1,300 tons, but the weight of the crane that holds the tower and moves it onto a vessel or off a vessel. So the load bearing capacity, or the ground bearing capacity required for these ports is enormous and far exceeds what you'd see at a typical container port or other type of marine site. I've spoken to this a bit, but I just thought it's helpful to kind of see it. These are some of the benefits of building unrestricted staging ports, like are used really everywhere else in the world. On the left, you see a port in Scotland that is about the size of Arthur Kill Terminal. They're fully assembling the towers on land, so that'll reduce the number of lifts and the amount of time it takes to put up a given wind turbine offshore. The towers, you can't see some of the other sections, but you see on the left side, these are the bottom sections. They can be manufactured in custom lengths, the different sections, but typically, between 3 and 4 sections per tower. So if you think about it, if you were to send those offshore in 4 sections, it's going to take 4 times as long to put the tower together. And time is money when you're using an installation vessel like the one you see on the right. That costs hundreds of thousands of dollars per day just to rent the vessel, and not to mention all the other carrying costs of running your construction project. The vessel you see on the right is the first Jones Act compliant U.S. built offshore wind turbine installation vessel. It's still under construction down in Texas. It's going to be used to build New York's first large offshore wind project, Sunrise Wind, out of State Pier in Connecticut. And then it'll go back down to Virginia to support a large portfolio of projects that Dominion Energy, the Virginia utility, is building there. This is again, a type of vessel that can't access New York Harbor. We'll be the only port in New York that'll be able to bring in this type of specialized equipment to do wind farm installation. There's a global shortage of these vessels that can handle the very large current and next generation wind turbines. So it sort of remains to be seen what vessels will be available for the US market and to what extent the US can build more of these in a way that is economic and timely and that can support the build out of those projects that I've showed you. So vessels and ports and transmission are sort of 3 major constraints in offshore wind in the US that folks are looking to address. Other benefits of being outside of a bridge, jacket foundation staging. So on the left, you see, I think, one of the world's largest jackets. These are alternatives to the steel monopile tubes that might be used for offshore wind. And it's a different type of design. It takes longer to manufacture. but it involves less steel. And so there's a certain sort of set of conditions for water depths and weights and other environmental factors and cost factors that may have developers considering these types of design for their turbines. It's important that developers aren't, forced to use a certain type of foundation technology because they don't have ports that can handle the full range of options. And again, we'll be a port that's unique in New York that can handle these fully fabricated jacket structures. And then here's a depiction of a floating offshore wind module, or two of them rather. Floating wind turbines are typically deployed by assembling them to their full elevation in the port and towing them out to sea. It's a lot more steel to build these floating structures than a typical fixed bottom. I might be wrong about that, but that's my understanding. It's an expensive technology. It involves different sort of load dynamics between the foundation and the tower. And so one of the ways that you can make it more economic to do these is to not have to use that very expensive fancy vessel, which, by the way, can't use its legs to stand on the seabed anyway. So these are, again, important types of technologies that we think will be needed in New York long term, and therefore New York should have ports that can support them. Like floating, there are also self-installing wind turbines, which aren't often talked about because they're more kind of demonstration scale. But there are ways of also building wind turbines that look kind of like this, but that you basically float out from the port to the sea, and then you lower them to the bottom. So they sit on the seabed, or they're connected into a pre-installed foundation, but they don't involve the typical, installation vessel that we showed you prior. So again, these are just benefits of unrestricted air draft ports in that they can really meet all of the different technologies and means and methods involved in offshore wind deployment. Here's a design showing you AKT. On the left, you have the Federal Navigation Channel. So that's about 35 feet deep, I think. And our dredge basin is in dark green. So that's the area that will be dredging between that channel, rather between the state border and the bulkhead line, which is shown right here. On the north side, you see this is a cargo vessel delivering components, in this case, blades. And on the outbound side, we've designed the port again to be able to handle wind turbine installation vessels. That vessel that I showed you a rendering of earlier, that first US Jones Act wind turbine installation vessel is shown here. And there's a couple turbines here, ready for load out on the outbound quay is what we call it. And then you have, I think 25 or so, 18, 20 megawatt turbines stored throughout the site. The blades are all stacked. The towers have been upended. This would be, one potential configuration that a user such as Leading Light or another company might decide to operate the port in. And in terms of the upland, kind of accessory infrastructure and uses, we have a tenant area. So this would be where they would be working from day to day, parking, office, warehouse. I'll explain more about that. And a visitor center consisting of a renovated historical home. That's going to be an interesting feature of our site. Just to put, kind of the project and the site in context, we spent a lot of time over the last few years studying the site, as any developer would. And one of the most interesting things about this site is that it used to be, filled out to the bulkhead line actually for about half of the quay. So the site, a lot of the soil sampling and natural resource studies that we've done, reflect this fact that, a lot of the species and trees and things that are there are invasives that have grown really over the last 40, 50 years. And we find that there's just sort of an odd mix of fill in the sediment, both upland and also in the area between where is now the current shoreline and the bulkhead line. So it's something that, I'll probably talk more about when some of us walk the site this weekend. Interesting to see also just how much Staten Island has changed. I know some folks are on this from Staten Island, and it's been fascinating to do the research about the history and of land use and things like that. And now I just want to show you renderings. So here's what the site, we think is going to look like without components. You see a little bit of a bump out here. This is where the heavy part of the wharf is a little bit wider, and that's to accommodate more heavy and wider cranes. So it's called a ringer crane that has a big circular foundation. But the rest of the quay and the bulkhead is really designed to support crawler operations, which can move all the way up and down and do lifting in as many possible configurations as might be needed by our users. It's been designed to include, access roads around the perimeter to provide emergency access and egress for, fire and other emergency reasons. And again, here you can kind of see some of the facilities that we've planned. And here's that example layout that I've shown you kind of in rendering form with the WTIV or the wind turbine installation vessel and the cargo vessel on the inbound side. We're also going to be building this bridge protection structure to prevent any vessel collisions with the unprotected columns of the outer bridge. The other columns in the water were recently protected via new piling system, but we're going to be extending that to cover the rest of the site, just as a matter of precaution. In case folks on the call are interested in marine operations and vessels, here's just a couple slides showing you what these inbound operations might look like. Again, we've designed this with the safety in mind, really in all respects. And so here's how a typical heavy lift cargo vessel carrying offshore wind components would enter the site and depart it. And then the same is true for WTIVs, which again would be operating in different ways, whether they're carrying components or not. And the cycle times for these vessels, assuming they can carry 4 or 6 turbines, would be fairly infrequent. So here's a bit of more information about the tenant area. This is a building that's about 22,000 square foot, slightly smaller footprint. It's got 2 stories. And again, it's primarily designed as a warehouse and office building based on what the major wind turbine companies need for managing their port operations. So the first floor has a warehouse, cafeteria space, lockers, that type of thing. And the second floor is, offices for administrative, project management personnel, engineers, et cetera. The building is designed to be LEED Gold certified. So it includes, rooftop solar, a lot of energy efficient, materials and finishes and things like that. There's also solar canopies over the parking area and going to be EV charging. And there's a lot of care and thought that's gone into how stormwater is managed on the site. So there's a bioswale feature, for example, that's going to collect the stormwater lot runoff and hopefully, turn it into green plants rather than move it somewhere else. And the site has about 111 parking spaces. It abuts the Port Authority's property. So, we've thought a lot about their needs for access and maintenance and security and things like that. And the site considers the need for street widening along Arthur Kill Road, which has been a major objective of the community for a long time, but hasn't as yet happened. And so for the extent of our frontage along Arthur Kill Road, we'll be creating an extra lane, which will again help reduce construction impacts and hopefully help alleviate congestion in the region long term. The building and the coal house have also been designed by a local architect, Tom Laporta, who's just been terrific to work with. Here's the building again. Not much more I can say about it, but we think it's a pretty cool design. And this brings me to the visitor center. So in the southeast corner of the site, there's this building known as the Coal House. It was built in the 1840s. It was denied landmark protection status. It had been modified outside of its, I guess, architectural character after a fire many years ago. And it's been really in a dilapidated state since. The pictures on top, don't maybe do it justice. And hopefully those of you who come on the site tour can get an up close look at it. But it needs a lot of work. It probably would cost cost less to tear it down. But we're actually pretty excited about, kind of giving this new life and kind of changing the floor layout in a way that will make it functional as kind of more of a visitor center and a place where we can have, training on safety and all things offshore wind, like a lot of things that I'm talking about today. We hope for this to be a space where we can, bring in members of the community and share our experience and share our knowledge, and again, have exhibits for local artists and, nonprofits and really whoever wants to use it. So we're really excited about the kind of universe of potential programming that we can bring to this space. And so if any of you have any thoughts or ideas, would love to connect with you about that. This building is also going to have, rooftop solar and EV charging, which is pretty cool. Just a handful of parking spaces. We're looking at, probably 12 or so, maybe room for additional parking for events and stuff inside the port as we may need. Again, this is also designed by a local architect who lives down the road. I'm going to try to move quickly because I'm killing a lot of time here. Economic impact estimate. This is a major infrastructure project that's going to create a lot of jobs. And we've spent a lot of time thinking about how to activate local workers and local businesses to really maximize the amount of the value of the project that is shared with members of the community. There's going to be hundreds of jobs during construction over a 2-year period, and probably another 100 to 200 jobs per year that offshore wind related port activity is occurring in the port. Those are direct jobs. Most of the jobs will be for union workers, for folks that probably don't have any current experience in offshore winds and might work for an electrical contractor or a crane company or as carpenters or millwrights or something else. And so this is a really unique opportunity, again, to create that connectivity between the local economy and workforce in Staten Island, which is really uniquely prepared to participate in this industry. So we're really excited about that. The project is going to have more than a $500 million direct, indirect, and induced cost in the region just associated with construction alone. So again, it's going to be a major opportunity for a lot of people. And we're right now actually in the process of preparing a construction RFP. And so we'll be initiating that very soon and really look forward to continuing our work again to bring in Staten Island and New York City workers and businesses, especially workers and businesses in disadvantaged communities, MWBEs, SDVOBs, et cetera. So we spent a lot of time, mapping out all of those resources and thinking about how to go about, really executing on the goals and objectives that we have for the project as we, contract the construction, build it, and then, hand over operations to Leading Light, who share all of the same goals that we have for, again, maximizing the inclusivity of the project. So workforce development quickly. Construction is a big part of that. Operations is also a big part of that. I've explained a little bit of that. Both the visitor center and the tenant building have been really kind of designed thoughtfully for training and lectures that will need to occur, whether it's toolbox talks in the morning or again, like OSHA 30 classes at night, or something far more specific than either of those. We're really thinking about how is this place going to work functionally to, create, a lot of training opportunities for all the folks I just mentioned. As an example of this, I know Shay's on the call, but our owner's rep also has, recently developed a GWO offshore wind training facility on a barge on the North Shore of Staten Island. The business is called TMI Waterfront. We've thought about having similar types of, physical training infrastructure on site as well. There is a lot of funding and resources right now going to training in New York. And so our objective is really to make sure that we have the space for it as needed. There are dozens and dozens of companies that'll be, working with us in that effort to make sure that the training occurs. And again, happy to connect with anybody about that later. Worth mentioning that we'll be building this under a project labor agreement, and it'll be operated under a project labor agreement. All of our New York offshore wind farm tenants are required to do that, and probably looking forward to do that. And so as a result of that, again, there's going to be a lot of trades of all disciplines that'll be involved in this. I was involved heavily in the Block Island wind farm construction, and we use probably every single type of trade in some form of activity assembling turbines on the site. So it's going to be again a major opportunity for workforce development, really specific to offshore wind, from folks that probably don't expect it. And again, the training of all these workers will really help position New Yorkers to be pros in the industry as the industry evolves. So there are projects now up and down the East Coast, as I've shown you, that are unstaffed, and there's tens of thousands of jobs for offshore wind in the United States. And so having these types of assets and this type of infrastructure is essential to creating those kind of manual labor, hands-on skilled jobs in offshore wind. Without ports, these jobs are going to be occurring in places like Virginia or Europe or somewhere else. So we really need to have this infrastructure to create the physical jobs and, again, the connectivity to a lot of these other resources that I'm showing here. So this is a map, for example, of some of the infrastructure that New York City has identified throughout the city to serve in various capacities in offshore wind, whether it's educational, academic institutions, infrastructure sites, public, private, research and innovation hubs. There's so many different nooks and crannies of New York, as many of you know, that really can be activated to play major roles in offshore wind. And it's very exciting to see, as the industry evolves locally, how so many of these dots on this map have become kind of important pieces of the puzzle, or again mobilizing all of our capabilities and resources to supporting offshore wind in some way, shape, or form. AKT, we're just a fraction of all the things that are going on. Again, we hope to be a big piece of it by, again, supporting this need for staging and assembly, but there's so much more to offshore wind in the region. And again, if folks are interested in any of this, I'd be happy to connect with you and see if I could help make introductions. In terms of our timeline, we've been at this for a long time. It takes a long time to develop big projects like this. Where we are today is we're really working through our permitting at the moment. We filed a lot of our permit applications last year and are sort of going through the process of refining our plans for construction and everything else with our regulatory agencies. So that's something that's well underway. I mentioned that we're in the process of preparing our construction procurement. That's something that we're working on day and night. So our construction planning is definitely well underway at this point, and we're really hoping to be in a position to proceed with construction, at the end of the year. And that's subject to, having, again, all of these permits and approvals, having leases in place with developers like Leading Light, which are really contingent on outcomes in the New York offshore wind solicitation, and receiving state funding that we're seeking for the project through that same solicitation. So if these things can all come together this year, we're looking at about 2 years for construction, just under 2 years. And so that would involve really starting as soon as possible in late 23 or early 24 to mobilize to the site and to build out the project. And then from there, again, 2025 and beyond, it'll be a place where hundreds of people can come and participate in offshore wind in a very real way. So the project has, again, over the last 4 years, engaged with a lot of folks. We're really excited to be here with you tonight and to to have the opportunity to walk with you all on the site on Saturday. So again, these are some other organizations that we've been talking to and have been supportive of the project over the years, and we look forward to continuing to grow this list and engage with stakeholders. And I've been talking for a long time, so would love to turn it over with some time left, hopefully on the clock, to answer questions that folks might have.
Thank you, Boone. That was so interesting. I learned so much. So exciting. I know that I have questions, but I don't want to monopolize the conversation, and this is very much an opportunity for folks from the Staten Island community and beyond to ask questions directly to the developer. So please, you can feel free to ask your question with your human voice, or you can type it into the chat box, and we're happy to receive your question that way. I already saw some questions in
I was doing my part to answer a few there that I thought I could handle, but no, my point was really just I tried to answer some in stride in the chat as Boone was doing a great job with his presentation. But yeah, at this point, if there's any further questions, now's a great time to discuss.
Great. Okay. So someone asks about hurricanes. What happens in the event of a Category 5 hurricane? Are these?
How do I send that, love?
Hit return.
Are these turbines designed to withstand those kind of winds?
It was 10 years ago that I was in Wes's shoes working as an offshore wind developer. And I remember very specifically thinking about hurricane risks associated with, New England offshore wind farms. So I don't have the latest information. I'm sure Wes knows more about it, but yeah, they're definitely designed with site-specific environmental conditions in mind, the offshore wind turbines. So as part of the development process that Leading Light and everyone else will go through, they spend a lot of time gathering data about their site. And a lot of that data, or part of it at least, is meteorological data. So wind speeds, currents, water temperatures, waves, that type of thing. And they use that information to, verify that whichever turbine and foundation or turbine that they're using, the nacelle, the generator at the top, is, sort of a generic product to some extent. They want to make sure that that generic product will comply with the project specific conditions. And then a lot of the structure, so the tower on which the turbine sits, and then the foundation, is all custom designed to the specific location where it's built. And so those include, hurricane conditions automatically because they're considered. And then you add also, a safety factor. So they're very much designed with environmental conditions in mind. They're very, very expensive pieces of equipment. And they're designed to last a long time. The fewer times that Wes and his team have to go out and fix something, the better off everybody is.
Got it. Thank you. Somebody has their hand up. iPhone 5.
Oh, here I am. Am I up?
Yes.
Am
we
I
can hear you,
unmuted?
please.
Oh,
Yeah.
okay. Yeah, a couple of questions. One thing, community access. Every time there's development, now the Economic Development Corporation sees the Arthur Kill as the Gold Coast, as in all the developers can cash in. And I got to tell you, I'm very pro this project. I've been working with Deputy Borough President at Burke for a long time, and this is something we have to do. There'll be some short-term disruption. Certainly trenching is going to disrupt the bottom, but mostly that's out at sea. One of the questions I wanted to ask is, you won't have ships going in and out all the time. Islanders have been cut off from the water. Kayak Staten Island, Natural Resource Protective Association, we're in the water all the time. And will there be any availability to get to the water?
So
Has that been thought of yet?
Yeah, no, this is something that we thought of immediately upon, commencing the sort of conceptual site plan development. And, these operations are, this is a working waterfront facility. and one that is, really needs as much space as it can possibly offer for offshore wind. And so one of the kind of compromises that, we've arrived at through many, many discussions with city planning and other stakeholders was, providing places for people just to walk down and, go up and touch wind turbines isn't going to be consistent with the need for, work to be occurring and there to be
Oh, that's
safe
safety. That's
setbacks.
safety.
Yeah, it's all safety based. These are very, very heavy loads and lifts, and you need to be, even if you work there, if you're not directly involved in operating that crane, you need to stand pretty far back. And so we've designed that. I guess I didn't touch upon this, but the visitor center that I mentioned, that home, the Cole House, we've actually designed that to include like an observation deck on the second floor. So it's not the same as being able to go and stick your toes in the water, but it's hopefully a place that can at least be used to help members of the public kind of engage with what's happening there and learn more about it while being, a safe distance away from what's occurring. So that's sort of the thinking that we have. And, if we had more space, it would be terrific to be able to accommodate something like that. But again, with a site like this, it unfortunately just wasn't a possibility.
Got it. Somebody asked a question that and uses an acronym that I'm not familiar with, and you may know. It says, will the proximity to the SIRT Arthur Kill station be used to mitigate parking needs? I'm not.
Train, Staten Island Rapid Transit,
Okay, gotcha.
Staten Island Railway.
Thank you.
Yeah, I mean, we've designed the site to handle parking on site because that's something that we need to do under the zoning requirements. So we're not envisioning that like workers will leave their cars at Arthur Kill Station. That wouldn't be fair of us to do. But it's good that you brought that along because one of the good attributes of the site is the proximity to the SIRT and to several MTA bus stops along the area. So public accessibility for a place in the South Shore of Staten Island is actually fairly good. But again, we're really designing the port to be able to have the parking spaces on site, consistent with the zoning requirements.
Thank you. Mary Ann asks, does the power from the turbine come to land by cable?
Yes, and I'm sure Wes is thinking a lot more about that than I am. But I will tell you that the way it works is, let's assume you have 80 or so wind turbines offshore for a given project. Those wind turbines are all connected to a central substation that's built offshore in the middle of the wind farm site. And they collect the power and then they increase the voltage and then they send it over a very long distance, either using HVAC or HVDC transmission to an interconnection point somewhere on shore. So, they're not going to be plugged into our site, and we don't have an electric substation right next to us. I think there are probably other places on Staten Island that have been considered by various developers. There's other sites on Long Island, New York City, New Jersey. That's where the power actually goes, but then from there it gets distributed in the grid to all of our homes and businesses.
Thank you. Can you address the effects on marine life and migrating birds and so forth?
Yeah, I mean, our project is in an area that is very kind of out of the way from a concern standpoint for migratory birds and marine life. We're not going to have wind turbines spinning on the site, for example. The offshore wind energy areas themselves, again, are really subject to a very drawn out and intense regulatory process where, the government takes a lot of information from a lot of stakeholders, gathers a lot of data to make decisions about, impacts to various species of the wind energy resources offshore. And all that information is, publicly available. It does take some time to read through, but I would encourage you to take a look at, some of the environmental impact statements that have been published for various wind farms on the East Coast. The Bureau of Ocean Energy Management is the regulator for those, and their website will have a lot of information about all the science of offshore wind.
Thank you. Mitch asks, what is the plan for a transmission and land-based substation, reinforcement, HVDC, converter station? Can you address those things?
Is Wes still on?
Yeah, Boone, I'm happy to take any of these. You're doing such a great job on your own that I haven't had a need to speak up here. But this one maybe makes sense for me to chime in. So I guess I didn't mention, I mean, maybe it was evident from the map that you shared earlier, but our lease and some of the other leases in the New York Bight are a good ways offshore. Ours is 80 miles south of New York City, south of Long Island. And when power is transmitted over that distance, there's certain ways to do it more efficiently than others. And to really the point of the question, at that distance, what's really required is HVDC transmission, so high voltage direct current transmission. And the grid operates on an alternating current basis. So if the power is transmitted through HVDC means, it needs to be converted back to AC before it goes into the grid. And as such, there needs to be acreage, there needs to be land to do that as well. So in terms of our plans to plug our power into the New York, to the NYISO grid, we're looking at a number of opportunities in the New York City, or what's considered the Zone J area or grid. And before it will plug in to the grid, in fact, we will site and build an HVDC converter station that again will convert the power back to AC or alternating current power, such that then it can connect into an existing or maybe a new substation, and then find its way into the existing grid.
As a follow-up to that, since in not too long future, we won't be relying on fossil fuels, can some of the old fossil fuel plants in New York City, like Big Alice, for example, be a candidate for that converter station? Is that possible? Or you need more space?
Yeah, there's a number of different and interesting and really promising initiatives ongoing. And whether it's the peaker plants or just the existing baseload power stations, there will be a long and very complex transition to phase those out, over decades. And whether it's land for a converter station, or maybe potentially land for battery energy storage sites, which can support grid balancing. I would say very much so. The expectation is that those fossil fuel plants will play a role in future clean energy generation and transmission.
Thank you. Maybe we'll take 3 more questions, and then we'll look forward to our walk on Saturday. I'm looking through the chat. If you'd like to ask a question, Jill, you have your hand raised, please.
Oh, yeah. Oh, thank you. Yes, I'm wondering, at this point, is it clear that the amount of energy that would be generated of clean energy would outweigh the amount of energy that is being used to create all this infrastructure and conduct the energy to us and so forth? Has that been analyzed? You see what I'm saying? Yes.
Yeah. Will the wind turbines produce enough electricity that's being taken into consideration, all the energy to build everything?
It's a good question. I mean, just like Boone is discussing, everything really Boone's company is doing is to assemble and support the construction of the wind farms. And there's many other elements of the supply chain that goes into that as well. And as such, there's a lot of energy that's required to build the supply chain and to manufacture the equipment and ultimately to install it offshore. I mean, the answer is there's extensive studies and analysis done to optimize, ultimately I guess at its most fundamental level, the cost versus benefit of an offshore wind farm. And, at the end of the day, it boils down to the what's considered I'll call it the net capacity factor for all things efficiency, for the wind farm. Ultimately, how much power is being generated relative to its ultimate nameplate capacity, and then furthermore the benefits that are provided to the local market through the job creation and local investment as well. So there's a ton of analysis that goes into that, and I guess furthermore, the short answer is very much so. Yes, offshore wind is of course it's clean energy, and likewise it's a very efficient clean energy. I answered one of the questions over text earlier, but certainly we need all forms of renewable energy, and offshore wind is inevitably going to be a major part of the energy mix. When it comes to offshore wind, it will serve a really important part because it is both efficient because of the stronger wind speeds and the more consistent wind speeds offshore. Likewise, the scale of the turbines, like Boone showcased in his photos and his presentation, these are giant. The scale is giant, and as such, there's major economies of scale. And then furthermore, like I also said, proximity to load centers. Sure, it's an 80-mile or so cable, but in the grand scheme of things, that's not that great of a distance for this scale of power generation. And as such, the benefits that offshore wind bring greatly outweigh the costs of offshore wind.
Thank you.
I read something like the return on investment, or the speed on which the return on investment happens is faster for wind than fossil fuels. Is that correct?
There's a number of really interesting metrics out there. There's one, it's escaping me the name for it, but it's the return on energy. Actually, maybe it actually speaks to Jill's question. How much energy, how long does it take to ultimately generate and recover the output of the wind farm relative to the energy required on the inputs, manufacturing the steel, installing the equipment offshore, all of the manufacturing, et cetera, et cetera. And I don't have the figures at my fingertips right now, but we did showcase this in our bid into NYSERDA, that offshore wind, in terms of any of the renewable power generation technologies, actually has the shortest return on energy, meaning that of all the inputs that go in, it has the shortest recovery back to zero to start being a net positive energy generator. And that's actually less than 1 year to do that. Thinking about all the steel, all of the installation, everything that goes into a wind farm, it takes less than 1 year to actually be generating more power than what it took to build the wind farm in the first place.
Fascinating. Well, that's exciting. I think that's a good way to finish up. I want to thank Boone and Wes so much for a fascinating talk. I learned so much, and everyone for joining us. And if you haven't had a chance to sign up for the walk this weekend, please do. I think there's a couple of spots left, and we'll look forward to seeing you there and then out at Arthur Kill. But thanks again, gentlemen. This is really fascinating. Really appreciate it.
Yeah, thanks, Boone.
Thank you all.
Thanks, Matt, Katie, and look forward to seeing you all on Friday at the site.
Take care.
Bye.
Good night.